What is going on, guys? Welcome to this Python tutorial series for data science. In today's episode, we're going to start with pandas because up until now we've covered matplotlib and numpy, and now we're going to build on top of that and introduce a new module, a new library, which is called pandas. We talked about that in the beginning of this series, and pandas is the library that allows us to efficiently manipulate and structure our data. So pandas offers us two data structures. First of all, the series and then the data frame. And a data frame can be thought of as some sort of SQL table-like structure or Excel sheet-like structure. So you have a table, you have columns, you have rows, and you have indices and all that. So it's pretty advanced, and it allows us to do a lot of data science operations. We can efficiently manipulate the data, we can sort the data, we can export it, serialize it, visualize it, and all of that. So Pandas is a very good library, and we're going to start out today with the series. So let us get into the code. As always, we first start by importing the modules that we're going to use. And in today's video, this is pandas as PD. So we're going to import the pandas module with the alias of PD because that's again the conventional alias that you give to that library. And also we're going to import, as always, matplotlib.pyplot. But in today's video, we're not really going to use matplotlib itself because we're not going to plot with the PLT module or with the pyplot module. We're going to use pandas for plotting, but we need the matplotlib pyplot module to show the plot. So we're going to use pandas for plotting, but in the end we have to call plt.show to show the plot itself. So as I already mentioned, pandas is built on top of numpy and on top of matplotlib. So when we plot something with pandas, it uses matplotlib, so it needs to be installed, but we're not really calling matplotlib.pyplot or plt.something. And we're also not going to use numpy. We're not going to import numpy because pandas uses numpy, but we're not calling np.any function or any attributes here. So let's get to the series. How do we create a series and what is a series? A series can be thought of as somewhat like a two-column table or a little bit like a dictionary. So we have basically values and indices, key value pairs if you want, or index value pairs. So let's just create a series here. Series equals pd.series with a capital S. And what we pass here are two collections or two lists. And these two lists are, first of all, the values and then the respective indices. So, for example, I can just say 10, 20, 30, 40. And these are my values, the values of the series. And then I can say, okay, they have the indices A, B, C, and D. And then I can go ahead and print the series, of course. Oh, I run the wrong module. Main, where is it here? And you're going to see that it's a little bit structured like a table. So it's not structured like a dictionary with the key value pairs in curly brackets. It's more like a table. We have the index column here, the key column here, and then we have the values belonging to these keys or indices. And then again, or also not again, we have the data type of integer 64. Of course, if I change this here to be a string, I am a string. It's possible it's not a violation of the structure. We can do that, but then the data type's object because we have three integers and one string, and that's of course not consistent. But I think if I make all of them a string, it should work, and it should say that the data type is a string. If I'm not mistaken. No, it's not. However, doesn't matter. I don't know why it's an object. Maybe I forgot something. However, basically the data type shows you what kind of data you have in this data frame or in this series. In this case, we're talking still about a series. And this is basically how it works. You have one column for the values, one column for the indices or the keys. And this can be used, of course, to create all kinds of structures like maybe a person with the keys name, age, weight, height, and so on, and then the values. And you may ask yourself now, why should I use this instead of a dictionary? And we're going to talk about that in a second because a series or pandas data structures in general have a lot of different functions and you can do a lot of crazy shit with them that a dictionary cannot do at all. But we're going to get to that in a second. But for now, let's talk about how to access the individual values. So we have the series here. And if I want to access, for example, let's just convert that back to numbers. I mean, actually it doesn't matter, but I don't like to have numbers in strings. Then I can just use the square brackets here and say, give me the element with the index C. And it gives me the value of 30. Yeah. So by the way, it's not about the data type here. So it's always the case that the second one, it's always the second collection is always the index collection. So if I was to swap the positions here, so if I say, okay, these are my values, and this is the second collection I pass, this would be then my index collection. So it's always the second one we pass is the index collection. The first one is the value collection. And of course, if we want to swap that around, we can. I think this should be possible. I'm not sure, but I think we should be able to do it like that. No, I don't think so. No, we always have to first specify the positional arguments and then the keyword arguments. But we can still, if we want, do it like that. Would be redundant because it's already the index, but you can also specify the index keyword here. Another way that we can do that I think is not possible with dictionaries is we can still, even though it's a key value pair based collection, you can still access positions or indices in the form of numbers. So I can say series.ilog, which stands for integer location. I can still access that and say, give me the position 2, for example. And then it will give me the position 2. Even though I don't have any index 2 or something like that, I can use the ilog iterator here to say, okay, give me the third element with the index 2, of course. And this is how we do it, like in an ordinary list, basically. This is, I think it's not possible with a dictionary. Another thing that we can do here is we can specify a name for a series. So we can say the series has a name, my series, and then when I print the series, I can just get all the overview here. So I have the keys, the values, the data type, and then I have the name, my series. So these are the basics of a series in Pandas. Now let's get a little bit more into the series. So what can we really do with that series and why is it superior to a dictionary? Now, first of all, we can even convert this into a dictionary if we want. It doesn't matter. We can just go ahead and say print dict. So for typecasting, just dict for dictionary. And then pass the series, and you'll see that it's no problem to convert this series here into a dictionary. So we just have the keys and the values. Of course, I think it makes more sense to swap this around again. So to have these as values here and these as indices. But basically, we can take any series we want and convert it into a dictionary. And with a series, we can do a lot more things than with a dictionary because a dictionary is just a dictionary. You can call the values by keys, so you can access the values by referring to the keys, but that's basically it. You cannot really call positions. You cannot really do any calculations with dictionaries, but with series, you can do all of these things. So what we can do, for example, is let's define a series as 1. And this series has the numbers 1, 2, 3, 4 with A, B, C, and D. And of course, we don't want a semicolon here. And then we have a second one with the same indices. So we still have A, B, C, and D, but now we have different values. For example, 7, 5, 1, 2. And what we can now do, what we cannot do with a dictionary, is we can just go ahead and say print s1 plus s2, and that's it. So what happens then is we just add the values that have the same index. So now we have A equals 8, B equals 7, C equals 4, and D equals 6. So we just added all these values, so 1 plus 7, 2 plus 5, and so on, because they all have the same indices. And I'm not sure again, but I'm going to try that. I think it also works if they don't have the same position. So now we have CBAD and ABCD, but I think it should still add 1 and 1. So still add A and C and C. But we're going to check if this happens. And of course it happens, yeah. So we take A and add it to A, and we take C and add it to C, and then we get the results. So the positions are not really important. It's all about the index. So this is something that you can do with series that you cannot do with dictionaries. Now, another thing is that we have a lot of functions that we can use. For example, we can just print as1.count to count the amount of elements in this series, which is actually quite basic. I think you can also do something similar with the length function in dictionaries. Um, but we can also just say, show me the first 2 rows, or show me the first 5 rows, or show me the first 20 rows. And this is something that we're oftentimes going to use with data frames that are pretty similar to series, but this is, for example, the head function and the tail function. So these functions give you the last and the first couple of elements in a series. So for example, as1.had6 would give me the first 6 rows of a series. As1had2 would give me the first 2 rows. And tails, of course, gives me the last row. So the last 4 rows, the last 2 rows, and so on. So we can just do that, and you'll see that the first thing, what's that? S1.tails, or tail. I think not tails, but tail. Yeah. So as you can see, it gives you the whole information with the data type and all that, and it just gives you the first 2 rows, and the tail function gives you the last 2 rows. So this is quite useful if you want to get an overview over the series or the data frame later on, but you don't really want to print the whole thing so that you have too much output. You just want to look at the first 5 rows to see how the thing is structured, and this is quite a useful function here that we're going to use in the future. Now, another thing that's quite useful is that we can apply functions on all the values in our series. So we can just go ahead and define a function my square, and I pass a number x or a value x, and I return x to the power of 2. That's a simple function. And what I can do now with the series is I can just go ahead and say s1.apply and refer to my square function without calling it, just referring to it. And then print the result here, and you'll see that it squares all the numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16, sorry. And this is quite useful because you can just take one function and apply to all the values at once, and it's not really difficult. It works kind of well, and you can do the same thing with the square root function and all different functions that you have. Even more complicated functions, of course, they have to return something. You cannot just print them and then expect something to happen. But basically, that's it, and it's quite useful. And another thing that we can do that somehow works also with dictionaries, but not in such a smooth way as it works with series, is the sorting of a series, or the sorting of a collection. So we can just go ahead and say print s1 dot sort, and then we can choose to either sort by index or sort by values, because um, a series is always sorted by indices, or actually not always, but in our case, it's sorted by the indices here, and also the values. So in this case, it doesn't make any difference, but in this case, it would make a difference because it's neither sorted by values nor sorted by indices. So we can just go ahead and say s2.sort index, and we would get a sorted collection as a result. So as you can see, we now have A, B, C, D, even though we started with C, B, A, D. And if I want to sort by value, I can just go ahead and say sort values, and we would have a different result. So it would now be A, D, B, C. And one more thing that I want to show you here is when we call a function from a series or a data frame later on, we always get a copy return. So when I say, for example, s1.sort values, what happens is it just returns me a sorted version, or it just returns a sorted version of this series. So again, in this case, it doesn't make sense, but s2. S2.sort values just gives or returns a sorted version of s2, but without applying anything to the actual collection. So we have s2 sorted, But if I do this and then print S2, you're going to see that it's not sorted because uh, it still has the same arrangement here. If I want to now apply this, one way I can do this, of course, is just say S2 equals S2.sortValues. But in Pandas, I also have a special keyword that is called inPlace. And if I say inPlace equals true, this is a parameter. If I say inPlace equals true, what happens is that we don't return anything, but we apply it on the actual series. So in this case, we would get a sorted version of S2, as you can see. Another very awesome thing about Pandas data structures is that they allow us to easily visualize our data. So in this case, I have a Pandas series here with 8 elements, with 8 values and 8 keys or indices. And what I can do is I can just go ahead and say s1.plot and then plt.show, and that's it. That already visualizes the values in the series. This is not something that you can do with a dictionary, because in a dictionary you have to take the keys, take the values, and then somehow prepare them for a plt.plot function, all that. But here you just say s1.plot, and that's it. And this also works with a data frame later on. We're going to look at that in the future, but this is very simple. You just have all the indices on the x-axis and all the values on the y-axis, and you can visualize it like that. But of course, not only with a line chart, you can just go ahead and say s1.plot, and now you can choose all kinds of different chart types. So for example, I can just say s1.plot.bar, and it gives me a professional bar chart, as you can see. So again, we have the labels here on the x-axis and the values on the y-axis. And of course, if you want a professional chart with different colors, with legend, with labeling, you need to use Matplotlib more. You cannot just use Pandas, but if you want a basic, quick graph, you can just go ahead and use the Pandas plotting functions. Of course, I can also use the bar h function for horizontal bar or horizontal bar chart, as you can see. And of course, one of my favorites, the pie chart. So s1.plot.pie, and that's it. And you get a bar chart with labeling in different colors, without percentages though. So if you want that, you again have to specify some more things. But this is pretty basic and it works quite simple. So histogram would be another thing that we can do. And it would give me a statistical distribution. As you can see, it looks kind of shitty because, you know, what you want to visualize here. It gives you basically the values and their frequency, but it works. It's just one function and you have the chart. And this is one big advantage of Pandas when it comes to data science. Now, one of the things that I really love about series and pandas in general is the possibilities to export to almost any data type. So we can take this series here and just say s1.to, and then we have all kinds of different possibilities to export. So we can go ahead and say to SQL. And if you have an SQL connection, you can just pass the series into an SQL connection. So basically insert it into the database. Of course, this is a little bit more advanced, but what you can also do is you can just say to string. So you can just convert the series into a string and then use string functions, for example, to extract some data out of it. Or you can go ahead and say to Excel. For this, you need another library. So if you just run this and try to save in an Excel file, you need to import a module, or you need to install a module that you probably don't have unless you've used it in the past. But basically it works, and you can also export into CSV files. Sorry. So you can just go ahead and say s1.toCSV, and I can say mySeries.csv. And when I run this, you'll see that it creates a CSV file with, what is that? Signature was aligned to data frame CSV. Oh, of course, yeah. But basically it works. So mySeries.csv, and you can see that we have A1, B2, C3, D4, E7, and so on. We have the series in our CSV file. And this can be done with all kinds of different data types. So we have JSON, we have dictionary, we have LaTeX, NumPy, Pickle, all kinds of different formats that we can export our series into with just one function. And this is also not possible with the dictionary, at least not that easily. And this is one of the great advantages of Pandas. So this was the first tutorial about pandas, and we talked a lot about the series. From next video on, we're going to focus more on the data frame because that's the basis or that's the core of pandas. Series are nice and fine, but we mainly use data frames because data frames offer multiple columns. So that's it for the series for today's video, and thank you very much for watching. If you liked this video, if you enjoyed it, if you learned something, hit the like button. Also, feel free to ask questions and give feedback in the comment section down below. And of course, as always, subscribe to this channel if you want to see more. And thank you very much for watching. See you in the next video. Bye.